right, now that we have the majority of class finally here, so let's go with class.
Yes.
Thank you. All right, now, I gave you guys this note yesterday. So what did I tell you to do with this? Go ahead. Yes, the circle. Now, the circle, very good. So you have your notes in front of you right now. So do me a favor. I want you to draw the circle on this one. You're drawing the circle on this one. Okay, and from memory, fill it in.
The unit circle or like the sine circle?
The sine circle, the derivative for the trig. I hate to break up this. Do your freaking work. Flip the page. You need something to write with? Okay. So flip the page, go to the slide, and now you're trying to fill out the derivative circle from memory. Not staring at his. It's that one, Karen. It's that one. How would you write it on the one? Yes. Because you weren't supposed to be on the previous one. You're supposed to be on, yeah. Because I'm asking you to try and do it from memory. I gave you guys some key information to help you do it from memory. You guys recall what that key information was? No? Yeah, the pluses and minuses and all that other stuff, like the ones and negative ones, right? So you should use that to actually do this. All right, so I'm going through. Circle. What's on top? Sine. Positive side, right?
Yes.
And then it goes down to? And then? And from there? And then back around.
So does that mean that the fourth derivative of sine is just sine?
Yeah. First, second, third, fourth. Yep. And what circle is this for? Derivative. ddx. We'll eventually do another one, which is the antiderivative. And what do you think that's going to do?
Well, are the arrows going to go backwards?
Yes, it is. Woo! Good job. All right. What you looking for? Hmm?
You know, I like how that's like a little notation for derivative. How would you write it as antiderivative? Is it just that?
Oh god, I remember those.
Integration.
That?
Yeah.
Yeah, I've seen that so many times. I already knew what it was.
Okay.
It looks like an F without the line.
I know. From A to B of f of x dx. That's basically what it would look like.
Did you have to actually like manually make those?
You will eventually. But at this current moment in time, I'm just telling you what it is. Now, you people will do A, B, and C. Right when? Right meow.
Okay, so
Right when? Meow.
oh wait, then I think I drew the circle on the wrong side.
Ah, some people.
I did, and you said yeah.
It's not like I actually walked over and looked at and read which slide you were on. Good point. So, answer to you for this point on is going to be no.
Okay. With the negative one in the front?
No.
The negative will multiply as part of the sine.
No, you have to.
What do you mean?
Or like it's like the negative
yeah. So yeah, it goes up right there.
Oh.
Yeah.
You just multiply this, so it puts up right here. What's 2 times 1? It's 2. And then subtract 1, so that's 2 minus the 1. And then so on and so on.
You don't have to do it in that little box. You know, you can use the lines off to the side, right? You can use the lines, any of the lines off to the side. So you know the lines off to the side, the previous one,
Yeah.
up higher, up higher, up higher. Right there, you can use those too because you're not using those lines anyway, right?
But it's not going to look like it. So what happened is, they tried to do the version of this manual and it can't
Walking in here almost 8:30, but you got your caramel douche bros. Yeah, you had to go pick up your douche bros. Your mom invited you, so your mom's the reason why that you are still, yeah, almost 30 minutes late to class. So I'll call her later on and we'll have a conversation. All right. But enjoy that douche bros. Which douche bros do you go to? The 107? Yeah. Okay, just like right, you're basically almost to school, but you have to wait in that line. Where did you actually like get out, or did you sit in the car?
No, I got it up.
Oh, okay. So you picked it up on your way. Okay, I thought you were one of those cars parked in the drive-through for like 40 minutes waiting for someone to actually, you know.
I would have taken gas.
Okay, thank you. Appreciate that. So that means that you started out already that late in the first place. Yeah. All right. So as you guys are working that out, I'm going to work out the first one. So continue your work. I'm just going to show you the answer for the first one. Hierarchy rule. All right, you can check your answer for the first one. All right, any questions over the first one? All right. I'm going to go to B. Let's see. Cosine over 1 minus sine. All right, continue working on the one that you're working on. I'm going to go through and show my work for this one. You guys could check B. I am going to simplify it. I'm going to fix it a little bit. I kind of want you guys to at least get to this point. So if you have this, this is still the right answer.
This would just be correct on
This, yes, this is the correct. So, but then on the AP multiple choice, they never put it in this format. So you'll see something that looks like the right answer, but you'll have to look to see if it is, you know, arranged, simplified, all that stuff. So
With sine is squared, would it be written as sine squared theta, or would it be sine?
yeah, sine squared theta. So the square goes on the end for each one. So this means the same thing as sine times sine, but then we're squaring the whole thing. But then if it was just sine squared, it was square goes over the end. That's just a notation thing. So, but if you put it in the calculator, you put it on the outside.
Okay, so it doesn't matter.
Yeah. All right. Okay, so I'm going to do a little distribution here. So that's going to give me negative sine x and plus sine squared x. Negative negative makes that a positive, plus cosine squared x over 1 minus sine x squared. Now, what is the one thing that everyone forgets about trigonometric identities? There's always one thing that everyone forgets. Huh? You mean squared, not 2x. That means something different. So sine squared plus cosine squared gives you 1. So that is the one thing that everyone forgets. 1. So this right here is going to give me 1. So if that's 1, I'm going to rewrite it. I'm going to put it in front of here, though. So I'm going to have 1 minus sine x over quantity of 1 minus sine x squared. And what else is that going to do? That's going to cancel out, isn't it? Because we have all this is going to cancel out with one of those. So my final answer is 1 over sine x. And this is all my g prime of x. Now, going from all of this down to this is normally what you see on a multiple choice type test. Because you're not just testing this, it's you need to do your work to actually get it down to this, to simplify to that point. You know I am recording this too, right?
Yeah,
you know.
but I just thought I could be just.
Oh, okay, yeah, just, record it, yeah. I see how it is.
I was just taking a picture.
Oh, okay.
Yeah,
Oh.
yeah.
I thought you were recording my explanation.
No.
Oh, okay, all right. All right, so yes, that one's for B, and we're taking a look at C now. You guys all had a chance to try C? Yes? No? Still working on it? Okay, so still work on it. I'm gonna work it out up here. So work on C, and then I'll come back to with what?
I don't know, can you keep solving it?
No, I did.
That's it?
Yeah, that's it. So
So then you would just combine the terms of e and t, cos t, and then like there's sine t, e and t.
okay, so hold on. So you're asking me to continue from there?
Yeah.
The only thing I would do is actually factor them out, because change that to a plus, and so it would be e to the t times quantity of cosine t plus,
E is sine t.
no, not e to the sine t, because I took that one out.
Where? Oh.
Remember, you common factor that out front, and that's where I get the quantity right there. And
I was thinking, couldn't you just if you multiply on like e to the t and cosine e and the other one, couldn't you when that came to like one, that rule where like cosine plus sine equals one, but when they gave both.
okay, so hold on. Come on up here, because I'm not sure what part you're talking about.
Like, so you see how you multiply right there, e t times cosine t.
Okay, get your butt up here. So you're talking about here from my formula, right?
Yeah.
Okay, do it.
Multiply those.
Where? So this is multiplied, right?
Yeah.
Okay, and if I multiply those, isn't that e to the t times cosine t? That's it. Yeah, that's it. Multiply them together. You just put them next to each other.
I know. You said like the rule was like cosine plus sine would equal one, right?
No, that's cosine squared plus sine squared equals 1.
Okay.
And so it has to be square, and it has to be a plus, and then there is some different combinations of this, but we'll talk about that later.
Okay, yeah, I messed up. Thank you.
Okay.
Is there a specific reason why now you're changing the order of everything?
I changed the order of what?
Oh no, it doesn't matter. You can switch it either way. Because remember, it's just negative. I was wondering that too.
Are you talking about from So this is.
On the worksheet, it says the G prime.
Oh yeah. Okay, so yeah, on the worksheet is different than the way I do it every time, because the quotient rule and the product rule are both the same. I put them in the same order, so that's always going to line up the same way. But I know that quotient has a minus sign and it's divided by g squared, where a product has a plus sign and it's the same order every time. So yes, it's slightly different than what is written on the notes, and I don't understand why that mathematically they decided to actually have them different. But yeah, you get the same answer though. Okay, so late.
Why doesn't the exponent for the trig stuff? Why doesn't the exponent go to the x and instead go to the trig?
So why doesn't it go to that?
Like, why isn't it cosine x squared instead of cosine squared x?
Okay, good question. I'm going to do this right here. I'm going to show you. So we're going to use the Pythagorean identity of sine squared x plus cosine squared x equals 1. Okay, we're going to use that Pythagorean identity. And I'm going to use a known value. So I know that I'm going to use pi over 6. So I'm going to say that x equals pi over 6. Okay, so I'm going to plug this in and I'm going to go with it like this. So what is sine at pi over 6? So it's the sine is the y value, isn't it?
Yeah.
And just think about it in your mind's eye. So pi over 6 is small. It's closer to the x-axis, isn't it? Yeah, it will be 1/2. So if you think of it like that, so pi over 6 and pi over 3 are opposite of each other. Okay? So whichever is closer to the x-axis, okay, that's the one that's further away, right? So that's going to get the rad 3 over 2. And then if it's close to the y-axis, that one gets the rad 3 over 2. So at pi over 3, the sine, the y value is bigger. So that's why that one gets rad 3 over 2. Okay, so I know this is going to be 1/2. So as I plug this in, this is going to be 1/2 squared. Because they're squaring whatever my sine is, right? Okay, so I think the notate. This is probably what's getting you.
Yeah,
That's the same thing.
I don't understand why it doesn't go to the x.
I know, I'm getting there, but for me to actually show you, I need to prove this to be true. And then I'll show you what happens if you change it. Okay, so now we're okay with that, right?
Yeah.
Okay, now what is cosine at pi over 6? Okay, very good. Square equals 1 squared. Okay, my Pythagorean identity, 1 squared is always just 1. And that's why it's not really shown here. It is the Pythagorean theorem. A squared plus b squared equals c squared. And c is the radius of my circle, and my radius of the circle is always 1, and so it's always just r. R is whatever it is. It is just that one value. And all my identities on the trig circle has a radius of 1, so we're working on from that information. So we can work it backwards because of that. All right, what is 1/2 squared? Okay, plus, what is square root of 3 squared? Over 2 squared. What does that equal? Okay. Now, I'm going to change to red because red means bad, incorrect, murder. So now we're going to say that it's going to be sine of pi over 6 squared. Like that. Okay, that's putting it inside there. That's what you're saying, right? Or here, before I put pi over 6, let's just call it the x instead, so I don't jump too far off. Okay, so that's putting it in the other place, right? And showing you the difference in between those. So now, if I say x is pi over 6, right? Let's square pi over 6. We get pi squared over 36, and we're trying to find the sine of that. Plus, again, it's going to be the cosine of pi squared over 36. That does not equal 1. I'll even pull up my thing here. Okay, so we're asking for the sine of pi squared, so pi squared over 36. It's in radian. Control Enter. And now I'm going to do cosine of pi. Come on, pi squared over 36. Control Enter. So I'm going to go here, Enter, plus, Enter, Enter. So it does not work. So Pythagorean identity is a law. It's a principle. It's used for so many things. In trigonometry, in all geometry, and it's a basis of a lot of our math, is the Pythagorean theorem.
So basically, because like that theorem is correct,
It doesn't work the other way. So sometimes we're going to have the x squared, which is actually the x itself is being squared, and then put into our value. That is going to be slightly different problems. Then we take whatever my value is, plug it in for sine. It's usually going to be one of my known values from the unit circle, and then I square it after that. Is that
we're just like basing it off the theorem, basically.
that's how I proved it. That's the difference in between the two things. So because you have an amazing question that has never really been asked to me like this, so I had to come up with a way to actually show you that they are not the same.
Are you still recording?
Yeah. Okay. So yeah, that's what I come up with to prove that these are not the same thing. So when we're squaring sine, that means whatever my value is at that, then I square it.
So you find whatever, the unit circle thing, and then you square it.
Then I square it. But if I do it the other way, I square the value that I'm plugging in, and then I take the sine of that value. That's the difference. Okay. All right. That good?
Yeah.
Karen? You're giving me that crazy look. Do you not like what I did? You don't? Okay. Are you okay? Are you okay with this? Okay, so of my known value at pi over 6, I use Pythagorean theorem. I could use any other value on, but those are things that I know. Sorry, I got a moron sitting there dancing at me in the door. Anyway, so Karen, you're kind of okay with this or not? Not okay? Okay, over here, do you not like this? You don't know what this is. Okay, so this, because his question is asking the difference in between putting my square there and putting my square here. Yeah, that's the difference. So this right here is malo. Es no bueno, es malo. Okay. Is it the little bit of Spanish I use that help? Okay, good. All right, where was I? I think I was right here, wasn't I? No. Where? Okay, so we're okay with this? Yeah.
Does it matter if you put X instead of T?
X then what?
Because what I did, I put cosine X and e to the X. Does that matter?
Cosine X and oh yeah. No, because yeah, we started. It's not going to really matter. We started with e's, so stay with the. So I noticed I put X here, so that's why I'm changing that. I put an X, so yeah. Because that's the same variable we use all the time, and so when they change it, it like totally messes me up. All right. So, other questions? Yes.
Does it matter if I do it like this, or does it have to be like that?
Can I finish the notes?
Yeah,
Okay.
keep it.
All right. So. All right. So here is an application of this problem. And this is where I'm actually going to end on this one right here for today. So find out points on the graph f of x equals x plus sine x where the tangent line is horizontal. Now, key words in my vocabulary, my tangent line is horizontal. Now, with your hands right now, show me a horizontal line. Very good. So, what is that slope? 0. So that information, it tells me I want to know where f prime of x equals 0. That's key. That's probably going to be one of the biggest things that you pick out of this whole lesson is remembering that right there. Is that already it? I thought we were done at 9. Sorry. Okay, so I'll pick up this one tomorrow. Make sure you guys all like, share, and subscribe.